Hello everyone, in this video I'm going to be showing you not only how to solve quadratics in the calculator, but also I'm going to be reviewing all the different ways that we could solve quadratics all at once. Now that I've shown you all these ways, it doesn't matter which way that you choose to do, just as long as you're able to solve any equation for any variable. That's the point of Algebra 1, is to be able to rearrange things and solve anything at any time. All right, so let's go through these steps with the calculator. These steps are meant to be used with a TI calculator. It says that the equation must be equal to 0. Let's look at this first example. We have negative 4x squared minus 3x plus 6 equals to 0. So the left side is already equal to 0. We're going to touch the y equals on our calculator. And we're going to set y1 as negative 4x squared minus 3x plus 6. We're going to change the y2 to just be 0. And this function that I'm going to show you right now, second trace, to get the trace function in there, the first thing we need to do is we need to push the second button. Okay, so my graphing calculator is a little bit different from yours. But let's look at the graph. And we see a blue line and we see a red line. It wants us to use the trace function. So for your calculator, you will push the second and trace button to do it. But for me, in this app, I just have to push the trace button at the bottom. And then I think I just touch the point. Oh, it gets a slider. Okay, so that's kind of useful, but it's not going to give me the exact answer that I want. Like, it gives me an answer that's really close to what I want, but if I want the exact intersection between the two lines, then I can't do it on this calculator app. So I'm going to swap apps over to Desmos. All right, I typed in the two equations, and on Desmos we have the two graphs showing right now. And then all I have to do is touch about where they would intersect, and Desmos is going to automatically highlight. And if I touch again, Desmos will give me the exact coordinate of that point. Whenever we do this, we are trying to find the intersection, and since this second point is at y equals 0, that's where the second equation's at. That means we're trying to find when the parabola is touching the x-axis, which is the same thing as finding the x-intercept, which is the same thing as finding the roots, which is the same thing as finding the solutions, which is the same thing as finding the zeros. Okay, so using Desmos, I can see that x is equal to negative 1.55 is a solution, and the other solution is at 0.8. And that's going to round down, so it's just 0.8. Let's do the next one. Okay, so we're going to keep the y equals 0 equation, and then I'm going to type in 5x squared plus 9x minus 126. All right, there's the graph. And if I touch around where it's intersecting, I have one intersection at negative 6, 0, and the second intersection at 4.2, 0. We are finding the x-intercepts, which are at negative 6 and 4.2. Okay, so I'm calling it the x-intercept, but that's just because this number on the right side is 0. In the next question, the number on the right side is not 0. So if we want to answer these questions the same way we have been in the first two examples, then I need to make sure that the right side is equal to 0. And that's what step 1 is saying. All right, so if I want this right side to be equal to 0, then I need to cancel out this positive 40. The opposite of a positive 40 is a negative 40. So we're going to subtract 40 on both sides. That's going to be 0 on the right equals 104 plus negative 2n squared. And that's the equation we're going to type in for number 3. And then we can highlight the two intersection points, which are at negative 7.2 and positive 7.2. Even though we put x on the graph, we're going to change it back to n whenever we're answering the question, because the question has n's in it, not x's. But in the graphing calculator, you should use x's, not whatever random letters are in the question. Okay? So we have negative 7.2 and positive 7.2. Let's do this next one. 8a squared plus 6a equals 5. The first thing we need to do is we need to make sure that the right side is equal to 0. So we need to cancel out this 5 by subtracting 5. On the right side, that makes 0, and on the left side, there is nothing for this negative 5 to combine with, so it's just going to be written as a negative 5 after all of the other terms. Now that we have a polynomial, a quadratic, equal to 0, we can change what's in our calculator to match that. I touched where the two lines are intersecting, the blue line and the green line. And I get negative 1.25 and 0.5. A equals negative 1.25, comma, 0.5. Those are the two values for a that you could plug in to make this equation true. Why don't we just go ahead and prove that right now? If I put negative 1.25, 8 times negative 1.25 squared plus 6 times negative 1.25, will that be equal to 5? Let's just open up a new equation right here and do 8 parentheses negative 1.25, close it, square it, plus 6 parentheses negative 1.25, close it, and we get that the answer for that is 5, which is exactly what we wanted. We got 5 on the left is equal to 5 on the right. It works. So I'm just going to go ahead and assume that if I plugged in the half, the second solution, that it would also work. So whenever we're rearranging these quadratics, as long as we're following the rules of algebra, which is if you subtract one thing from the right side, you have to subtract it from the left side. You have to keep your equations balanced. You can't just randomly add and subtract things unless you randomly add and subtract it evenly on both sides. That's okay. And with a calculator, especially Desmos, it's super easy to check to make sure that you're getting the right answers. Go ahead and try number 5 with me right now. You do it, and then I'll show you the answer in a bit. All right, if you look at this one, just looking at the graph, you can see that the two equations, the parabola and the line, are not touching, so that means that there's no solution to this question. You cannot plug in anything for x to make the original statement true. And here's where I'll show you the extra practice of how you could do it anyway. You don't have to use a calculator if you don't want to. You could factor it, or you could just do it like normal. So number 6, I'm going to show you how you can solve it by factoring. If we subtract the 25, that'll be 4x squared minus 25 equals 0. If we do our factoring chart, that's 4 times 25 on top and a 0 on the bottom because there is no b. Things that multiply to make 100 and add to make 10 are 10 and negative 10. Sorry, we want them to add to be 0, so we need them to be the same thing and cancel out each other once we add them together. Those are the factors, but then we'll divide them by 4, which means that this is going to change to be x plus 10 over 4, x minus 10 over 4 equals 0. And then we could solve this like how I just showed you a couple days ago. X plus 10 over 4 equals 0, which means that x equals negative 10 over 4, which is 5 over 2, but negative. Or x equals, okay, well, let's set up that second one. X minus 10 over 4 equals 0, which gives us the answer that x is equal to 10 over 4, which reduces to 5 over 2. So our answers for x are plus or minus 5 over 2. Alternatively, you could graph this in the calculator. And get that we have a solution at negative 2.5, positive 2.5, which is the same thing as 5 over 2. So the graph gives us the same answer that factoring did. And you would also get the same answer if you did the quadratic formula. But I think that these two ways, either graphing or using the factors, is going to be faster than using the quadratic formula. But before you do any of the types, just make sure that you're making sure that the right side cancels out and you end up with 0 before you start solving it. Okay, finish this page and also the next page. And that should be just fine for you.